Hey guys, welcome back to another video. I want to explain why I haven't been uploading much for the 6 subscribers who do watch me on a daily basis, well, constant basis, but the reason is school hasn't been easy, and since Corona has messed up the school system, they're gonna be pushing a lot of things at once at you, so I took a little break from YouTube and hopefully I'll come back full swing. So in this video I'm just wanting to get back to it. So this one will be just explaining the difference between functional and object oriented programming. I'm hoping that you know what OOP or object oriented programming is, and hopefully you know what functional programming is, but I wanted to explain when you would use them and why you would use them. And yeah, if you found this video helpful, make sure to subscribe and like, and let's get right into it. So the first thing we want to do is create a Python file. So I'm going to call this app.py as usual. And if you want a quick brush up on functional and object oriented programming, I'll show you. So let's make a function if my laptop loads. So def for define, and we'll do student grade, and we can get a parentheses, and inside the parentheses we can establish parameters. So we can do name. If our program is a very slow, name, we can do year group. So we'll just write year, score, and then let's just say something like max score. And what we can do here is write a little algorithm where it takes the student's score and we work around and figure out what grade they should get. So using the score we can get a percentage using the score max score. So what we can do is percentage is equal to score divided by, we'll do a hard divide so we don't want to be left with a decimal, and then what we want to do then is just multiply by 100 and you should be good. Let's just return percentage, see what this gives us, and print student. We can just do, oh, this isn't necessarily returning it, we just want to return it. We just want to, let's just give it my name below. Year, I'm in year 11. We can give this a string, so 11s3 for like a specific year. I'm going to keep it like that. Score, let's say score of 45 and it's out of 70. Let's run this and see what happens. Okay, that shouldn't necessarily return 0. Let's return this, run this again. Okay, so let's get rid of this hard divide, see what happens. And we got 64%, and if we just pull out the calculator, we'll do 45, I think it was, divided by 70, and then multiply by 100, and that should give us the number we were given by Python. So this is working as it should be, but we obviously don't want it to be this long, so we just want to truncate off the decimal. So what we can just do is hopefully round to 0, However, this will give us a floating number, so after we've rounded it we can turn it into an int, and hopefully it works. Let's run this and we get 64, and this should be an int. We can do the type function on it, but we won't do that now. Just want to clear that. So now we want to use this percentage to figure out grade, and how grades in the UK work is grade 9 being the most, and 9 is basically an A star, A is an A, 7 is a, actually sorry, not A, 9 is the A star star, 8 is a A star, and 7 is a, and 8 being a, sorry, 6 being a B. So it goes 9 to 1, 1, well 9 to U being ungradable. So what we can do is we can set a empty variable, not really empty, an empty string, a variable saying grade is an empty string, and then we can do if percentage is greater than, let's say, 75. Let's see, grade, actually 85. I'm just gonna do this conditional flow, come back once I've done this conditional flow. This part's gonna be repetitive, but once I come back I'll explain what it does if you're not aware of what it does. So I'll see you then. Okay, so I'm back and I'm gonna quickly explain what this algorithm does. So basically we get percentage, and if it's greater than 85% or equal to, we get grade 9, and it just goes down if it's greater than 70 and less than 85, so grade 8, and then instead of doing D and E and F, I just did ungradable if it's less than 50%. Obviously this isn't the case in the real world, but I just shortened this down so much. And also one problem you may see here is that this is repetitive, so there's ways you can optimize this, but just for time's sake I won't be optimizing it, and keeping it simplistic is best for this tutorial, as I'm just demonstrating the difference between a functional and object oriented program. So if you run this, we get a student grade, we get name, a year, a score, and max score. So we just run and we get grade 7. If you remember, this calculation gives us 64%, and if it's equal to or less than 64, equal to or greater than 64, we get grade 7. If it's 44 marks, we get a grade 6. But let's look at this. If we want to scale this function, we would probably have to create another function and then call that other function within this function. So let's say if we want to scale this, where we want to store the user's grade into an external file, then we could do it inside of here, but then that will potentially mess up the, you know, the purpose of this function. The purpose of this function is purely to find out the grade and not to do multiple things at once, since you want to separate out different purposes. So that's one limitation with function, is that if you want to make this thing scalable, then it will be difficult. It's possible, but it will be difficult. And another issue is, well, not another issue, one good thing about function is that it's really easy to use and set up. Obviously, we don't have any instances we need to create other than object-oriented programming, and we don't have any methods we need to call. And if we want to call this function, all we need to do is give the values, and then it'll return the output from those values. So functions are very simple, they're very quick to start with. If your functions only serve, well, if your entire program only serves one purpose and you're not thinking to scale it up, then functions is great. But I'm gonna demonstrate an example with object-oriented programming and then explain why it's good to use that method and why it may not be good to use that method. So I'm going to comment this out, delete this call function, and pretty much do the same thing, but obviously class student grade, we don't need to inherit anything, but we need to create a constructor. So we do an underscore init underscore, and then in this constructor we give it parameters just like a function would. So let's say name, year, score, and then max score, and then we need to, oh, one key thing I forgot was self. So self needs to be at the start. So self.name, name. Let me fill this out quickly. Okay, so the reason we did a def underscore init here, and one key thing with object-oriented programming is that yes, we can use these variables within the object. However, we can also call them outside, and I'll demonstrate how you would do that. But you can use these variables within the class itself and outside, whereas in the function you can't use these parameters outside the function, you can only use them within. So using it like this is very neat if you want to be able to call specific values very quickly. Let me demonstrate this now. So let's create an instance which will be s1 is equal to student, and this again. I think I've deleted 90. One other neat thing with classes is that there's way more wizard methods or dunder methods that you can use than underscore, and that will really help you with certain things. They could be very specific, but if you know classes well, if you've learned classes well, then using dunder methods will really help you out. Some to name are like dunder str and dunder, well, I can actually name some out doing this. I can't. Oh yeah, I can. So here are some things you could use within the method. I'm pretty sure there's way more, but you can look them up within the documentation. But if we create this instance s1 and then we do print s1 dot max score, let's say run this, we will get 90, and I'm pretty sure this was supposed to be 70 actually. Run this again and then we get 70, and obviously we can use these values inside of the class. So I'm gonna recreate this algorithm but within the class. So I'm gonna come back once I've done that. Okay, so I've pretty much copy and pasted the algorithm from above with the changes of making these self-dot score and self-dot max score, and that was pretty much it. So if we call this S1 student grade with this information and we run this, we get the grade 7, and it'll work if we change it up. But essentially this code here is pretty much the same thing as the function. However, if you look at it, it's actually way more lines of code. So setting up a class takes much more lines of code, whereas function is really easy to set up with. It's very quick. You don't need to set up any sort of constructors. You don't need to set up any sort of methods. So doing something like this is great. So the purpose of a class is to be scalable, and it does this by introducing methods, and methods uh, relate to the purpose of the class itself. So we know this class is to do with student grade, so we can make a method of calculating the student grade, another method of, you know, exporting those grades onto an external file, and we can do other methods for other cases, and this keeps the code really clean, and it makes it really easy to scale up. However, the downfall here is it's not very easy to set up. It takes a little bit of thought of thinking of what the instances should be, thinking of the methods, and it could take some lines of code. But we have a construction here, but there's other wizard methods or Dundo methods we can introduce where it makes the class much more easier to use. However, with the function, it really is easy to set up. All we need is pretty much the input, the parameters, the calling, and we feed the parameters by calling it, and then the algorithm itself, and then the output, which is also return. And this is fairly short. However, it can be very difficult to scale it up. So when you're making a full-blown project, let's say if you're making something like Netflix, but you want to make sure you add new features to the website or app all the time, so something like scalability would be more valued than how quick it's done. So functions are great for getting your ideas out very quick, but you may want to think about object-oriented programming for the long-term aspects of it. So I know this was a rush video and there may be some details I missed, but as I said, I wanted to get back into this, and I didn't want to get back into it with a lot of work. I wanted to ease it into it. So I'm pretty sure the next video I'm gonna upload is gonna be much better quality than this one. But if you did still find any value from this, or if you found this video entertaining at all, make sure to subscribe and like, and I'll see you in the next one.